Okay, we'll get started here. Again, welcome to Applied Day. This session is titled Supporting the Factory. I'm joined by Steve Thompson, our Professional Services Director. You'll hear from him in just a minute here. But before we dive in, I just want to give a quick background of applied engineering. For over 35 years, Applied has been helping companies overcome their engineering challenges, whether that be with our technology team providing training, implementation, and support for software and hardware solutions, or our services team providing design and manufacturing engineering, as well as software development and reprographics. Applied fits your needs. So yeah, with that, I'll turn things over to Steve Thompson.
Well, hello everybody. My name's Steve. I'll be going through, how we're supporting the factory. We'll go through a couple of these introductory slides, and then we'll kind of get right into it. So as you see on the screen, we still have two more after today. Today, Wednesday the 26th, 2 o'clock, that goes to our print and imaging services, and 3 o'clock is embedded service systems, which is a really cool one too. So let me flip through these. As Emily said, training, technology, services, we grow with our customer and do what our customer needs. We're very customer focused. So supporting the factory, why is that important and what does that have to do with anything? So what we did, we put this together to just talk about kind of this all applied days, I should say, is knowledge sharing events. And so whether you're talking about the presentation just prior to this on analysis or the one later in the day on embedded systems, it's to share knowledge about these things that we get involved with, and hopefully you can, it provokes some thought, and maybe you can take something away from it and find out, hey, yeah, this would be really good for our team to maybe investigate. And if you don't have the resources, you can always talk to us, and we can, let you know. Because all these projects, it's all about having the right resources, the right engineers, and enough engineers. And so that's kind of where we fit in. So with that being said, I'll just kind of go through what in all these examples I'll go through are very recent examples. Most of them are within the last year of just things that we're doing on the applied side to help progress factory operations. And so we'll go through that, but here we go. The different topics we're going to go through. I'll just give you a brief introduction about myself. Emily kind of already did that, so that's cool. We'll talk about jigs and fixtures. Well, you guys can read the screen there, the different things. And I'll talk to you a little bit about why we got involved with those, and then what the solution was kind of coming out of it, what worked, that kind of stuff. So again, I'm Steve. I've worked in the product development world for 25 plus years. Worked in many different markets. I've been on the business development side. I've been on the engineering side of just doing the work too. So I've been fortunate to be able to work with many customers over the years. And so I get a pretty good breadth of knowledge on what we see anyway. So a good place to start this whole thing is identified projects. And this is what we're talking about here is we meet with many different customers, and virtually all of them have some type of, whether it's suggestion box, whether it's a Kaizen event that they had a bunch of actions they needed to do, maybe just things that people have mentioned, hey, we should do this. And one customer that we met with actually had a list of over 2 pages long full of projects that they had already determined that it was a positive ROI for, meaning return on investment. So they already know when this gets done, it's going to save them money or add money or whatever. They'll get the money back out of it. Unfortunately, they didn't have anyone to do the work. So this is a really straightforward way applied, or just determining your own priorities could help out and just progress the factory, move things forward, get things done. And a lot of times it's just not thought of as an option, but we have well over 115 engineers on staff, so we have a lot of capabilities that can help out on this. Just get these things done, these projects that have stalled out, just because everybody's running so lean. There's not extra resources to get things like this done. But this is identified projects is a big one for us. We do it very regularly, and I would suspect that most people that are listening today have these lists and have gone, and it just gets to a point where we just can't, we don't have the resources for it. But you already know that there's return on investment for all of them. So that's the first one. Jigs and fixtures. Well, this is pretty straightforward. We do a ton of these, as long as anyone doing manufacturing or supporting manufacturing. Um, the jigs can be, or fixtures, whichever you like to call them. They can be anything for as simple as a Desteco clamp holding down a couple of parts for welding. There are also, we go into, we kind of look at it in a couple different phases. You can do, manual clamping, hydraulic clamping, air clamping, all sorts of different things to hold out your parts. Everyone's a little bit different, but also assembly, quality control, safety, many different aspects of jigs and fixtures on the floor. One example we have that we did a few years ago, which was really cool, was an assembly fixture. They were smaller parts, but they were very, very important to get exactly right. The fixtures itself were done in 2 or 3 stages as far as each assembly stage, and they had a PLC controlled and locks and optics to make sure everything was done just perfectly. And when it was done perfectly, it would green light the whole thing. A part would unlock, you could go to the next one. So every one of them was 100% accurate. And that's the key for jigs and fixtures, is getting repeatability and saving time. Whether it's quality control, it's a go, no go gauge, or things like that, it's all about saving time and getting consistent. Safety and guarding. This is the one we've gotten into recently with one of our organizations that we work with, in the fact that many companies have equipment that maybe wasn't originated for their environment they're in, or maybe it's older equipment that didn't have a lot of guarding and different things on it. And now, ever increasing refinement of production facilities, safety is always a top priority. In many cases, it's required now to do some guarding or different things like that, where it hadn't really been required or thought about in the past. And so there's an incredible amount of options for guarding that you can go into. Kind of the picture on the left is a visualization of a laser curtain. If anything crosses that laser curtain, the machine locks up. More traditionally would just be, some plexi or just see-through guarding, just to keep the chips and different things out of the way. Pinch points is another big one. Anywhere chains, anything rotating are all areas that need to be guarded. And most of those require a little bit of custom design and fabrication, and that's something that is very important and needs to be done, and that's another area that we've found to progress the factory. Connectivity is become extremely important, to the tune that you can walk into factories and get a pretty good read on how organizations are using technology by looking around. Some of the different areas that we work with is the integration of MRP, ERP files, whether that's coming from engineering to a manufacturing BOM. Some of the information about machine data. There's different sensors and things out there these days that you can now very readily monitor. For instance, you have a brake from 1954 and it still works just fine, and you've been using it, but there is no electronics on it. there's no sensors. So if you wanted to monitor how often that brake is cycling, there would be nothing from the factory that would be on that. However, if you are interested in looking at how often that brake is cycling, at what time, what's the effectivity of that production or productivity of that machine, we could hook up, or you could hook up some sensors and just Wi-Fi them, so you could get create a dashboard that says, hey, this brake is running once every 12 minutes or whatever, and it'll graph it all out. You could identify, hey, the brake wasn't running for these hour and a half. What happened? You could real time go down and figure out, oh, there was a part shortage. Okay, why is that part shortage going on? So we've been working with a lot of organizations on dashboards. KPI, key product indicators, are just the things in your organization that you really watch. Every company has them, whether it's tack times, whether it's how many machines are going out the door, uh, all sorts of different cycle times for different machines. Those can be incorporated these days with technology, Wi-Fi signals, to get a real-time dashboard for anybody to watch anywhere. Management wants to know how everything's moving along. You got it. We can make it happen. And that kind of data helps because it allows you to address the problem earlier, which reduces scrap. For instance, if you get to the end of the shift and all of a sudden you go, okay, how many did we get? You get the report and we got 15 made. Well, we were supposed to do 35. What happened? Then you have to investigate what happened. And so you're going backwards and you're trying to do kind of a forensic analysis of what happened during the shift. However, if you have the KPI on a dashboard, you can see right away before that at 9 o'clock, they ran out of parts. And so they could be addressing that situation by 9:30, 9:15, and get that resolved and actually save the production, save the productivity for the day. So the ROI on things like that are incredible. It does take, we spoke to several customers about it, and it really does take a little soul searching, because if you don't have those KPI already established, you need to figure out what you want to measure, because you could, the flexibility for doing dashboards and KPI is wide open. So to try to identify, hey, what are the KPI? But the key part of that is, it's flexible. You could start with one area, start on a couple machines, kind of learn that pattern, add a couple more, and down the road you find out, oh, this really isn't an important indicator to us. You can just take it off. It's not a big deal. And that's the beauty of working with this kind of technology. Reverse engineering. This is one I didn't think of until one of our customers started talking about it, but a lot of organizations have some specialized equipment. Usually they're made by specialized manufacturers. And as that equipment ages, the parts sometimes get more and more difficult to get. It gets more difficult to get, especially now, in a timely manner. So, and the cost can be extremely prohibitive. So what we've done with one of our customers now is we have a team that just goes through and takes care of that. They were having long lead times for their equipment. It was very expensive. And so we're doing it and going in and reverse engineering some of the key parts, the wear parts that they know are going to fail, or even parts as they fail. We take care of it, design it up, get it fixed. They fabricate it right in their shop, and it's out the door. And cost is a fraction of what it would be on cost, including all the reverse engineering costs. And also the turnaround time is a tenth or less of what it would be if they had to order it. This specific place orders machines are custom from Europe, and all this. And as everyone's struggling with parts these days, as far as being able to even get them, it's a pretty slick way to try to circumvent that process. Factory layout, another big one. This one seems a little more obvious, but just because when you're doing a factory layout, that's an obvious area where you need some help. That's usually a very high surge of resources. to, running the plant is one thing, but when you're running a plant and then they're taking on the challenge of a plant expansion, changing around how the processes are going to flow, just moving lines, it's an opportunity to kind of reassess maybe the flow of how things move, maybe material handling, different things like that. Um, it's a really nice thing. And so what happens is we can come in. We're not going to do the structures themselves. We're going to be involved with, okay, the structure's here now. How do you want it to be laid out? And there's a number of tools that can be used. Factory CAD can help out with mapping out processes and then working on the efficiencies of those processes so you can pull out some of the non-value add right out of the gate. Maybe adjust things in such a manner that the lines are fairly well balanced right out of the gate. One of our customers has really gone into this wholeheartedly and has literally saved the ramp up time in production of several months. They ramp up several months faster by doing this all ahead of time, which makes total sense. But it's just the realization that a lot of the bugs and the hiccups of plant expansion can be taken care of by doing some digital simulations or digital prototyping of the line, to the point that you could do full ergonomics on the different sections or the different stations. And that's a really a big deal too, depending on what the priorities are of your organization. But this can go soup to nuts, where to drop a couple hydraulic lines or pneumatics or power, for the different machines, to doing ergonomic studies right within the digital space before it's ever done, and adjusting, jigs and fixtures and things accordingly, making sure that the factory workers have access to everything they need to on the piece of equipment. When they're reaching in, they're not creating some funky angles, or they can't do certain things because they can't see, or those can all be eliminated. So pretty crazy. There's a huge push in this area. It's very well justified as well. Supporting the manufacturing lines, that one's pretty straightforward. Most organizations have a manufacturing engineer assigned to each, or multiple engineers assigned to different product lines. And we've just been working in kind of augmenting different organizations, especially with the tight labor market. They need some support, and it's just simple day-to-day support of working directly with the production workers, and then figuring out what's their hangups, what are they having trouble with, what can we figure out, what are the quality issues, and then it's a matter of root cause analysis. The 5 whys, whatever system you want to use, because you can, by doing those and addressing the problem as you go along, and when it occurs, then you save all the scrap and all the production problems in the beginning. And it gets back to Deming and his theories on production from way back when. And you just have to address the problem when it arises, and not keep forcing parts down and try to patch them up later. You address them right away, get to the root cause, fix it, and then the problem won't reoccur. So that's something we're doing for a number of organizations every day. I had to get a drink of water. Here we go. Documentation. There's another hot topic. Speaking of labor, finding just well qualified or even qualified production workers is difficult these days with a tight labor market. One of the customers I was just with recently, their big thing is they'd had a very consistent staff out on the factory floor for many years. Well, they started to retire, and all of a sudden the knowledge that Bill Smith had out on the floor of how to take care of this part or trim this part, maybe it had changed over the years and they figured out a solution, but nothing was ever documented. Well, now it's become an issue because all that knowledge, personal knowledge that they'd had, retires with them. So that in that case, it was an important step for, you know, what what are the work instructions? What are the accurate work instructions? How should they be doing this? Those have come a long ways as far as using digital models and clarity and video and all sorts of things to be able to really create a very effective work instructions. And then also just documenting what does our factory floor look like. Most organizations have added a mezzanine here or kicked a wall out there or added a machine here, but the documentation of what is the current state of the factory floor hasn't necessarily kept up with that. So we've done that numerous times, is just come in and say, people say, hey, we want to do some changes, but we want to run some simulation, but we don't even actually know what we have right now. So getting that current state documented, so you can say, okay, yeah, okay, here's where we're at. Now we can say, okay, what if we move this here or move that there? What's that process look like? What are the times involved with that? So that's a very, very important aspect too. And it's just a matter of you're always trying to keep up with production. Production's the number one priority, but uh, if the documentation isn't kept up with, that's gonna turn around and bite you eventually. And so we can jump in and help out, knock this stuff out, and then get out of the way. And that kind of leads into one of the last things here is the scenarios analysis. This is incredible advancements in this over the last probably 5-6 years of how to do analysis. And I mentioned it a little bit earlier, a few slides back, about setting up the factory floor. This is a lot of that comes in with this. That can be done prior to production starting, on a clean slate, if you will. But a lot of times there is no clean slate. It's just a matter of we've been tasked with, we have to get 15% more of these products out the door this year, and we have no idea how to do it. And so you can start to, either you start to wrench and move and physically move stuff around and try it, or you can say, okay, let's try to figure this out digitally. And you map in your current state. Then you can start playing around with the different processes and flow, whether it's, line balancing, whether it's adding another fixture, if you got a little bottleneck here, or adding another machine, or all sorts of different variables you can play around with and see if you can get that end number to achieve where you want to be. And a lot of times you can even go beyond that. But it's just a matter of taking the time and understanding those processes, understanding how they all interrelate, and then playing around with some variables and see if you can make it happen. So that's an exciting area for manufacturing, just because in a lot of times, in years past, it's thrown over the wall and here we go. In the concurrent engineering world we live in now, hopefully manufacturing can involve much earlier in the process and can take some time, have the resources, say, okay, how are we going to do this? We're just going to throw it on this line. Well, what's it going to do to that line? We're going to rob Peter to pay Paul. I mean, what's going to happen? So you can kind of do some predictive analysis, which in the end is extremely valuable, because the time on the manufacturing floor with all that labor, different inventory and thing like that is extremely expensive. And if we can save time there, it's a good move for the company. So I've talked a little bit about jigs, fixtures, safety, connective material handling, reverse engineering, all sorts of different things. And so if you have any questions, you can certainly shoot them out. Otherwise, I don't want to be take up everybody's time is precious. And so if you have any questions about any of this, you can always send me an email, or you can go to the sales@applied.com, go to applied.com. That'll get directed to the appropriate person. We have some more stuff going on in the future. If you want to learn a little bit about Autodesk, AutoCAD Electrical, Inventor, Vault, the new versions, there have some online seminars coming up soon, so you can sign up for those. And if you're interested, there's a couple more presentations yet today. 2 o'clock print and imaging, and 3 o'clock embedded systems. So if there's no questions, I'd like to thank everybody for their time, and I hope that they have a tremendous rest of their day. Thanks.